Welcome back. Last time we had looked at rational expressions, which are like fractions in algebra, and we looked at simplifying those expressions. Today we're going to look at adding and subtracting rational expressions. The first type of rational expressions we're going to look at adding are ones with like denominators, ones where the bottom is the same. As in fractions, when the bottom is the same, when the denominators are the same, you can just add the tops. So, in other words, P over R plus Q over R, as long as this is the same, R is the same here, we can just add the tops to get P plus Q over R. So let's take a few examples of this. In this example, we want to add 5m over 2n plus m over 2n. We notice that the denominators are the same, 2n, so we can just add the tops. So 5m over 2n plus m over 2n becomes 5m plus m over 2n. And now because these are like terms on top, we can write 5m plus 2m plus m to give me 6m over 2n. Now this problem is not finished, because as I might see, this 6 over 2 can be simplified. 6 over 2, well 2 goes into 6 3 times, and 2 goes into 2 1 time. So my final answer would be 3m over 1n, or just n. And here's our answer. In this problem, we have to subtract. We have 2y divided by 2y minus 7. Subtract, or minus, 7 divided by 2y minus 7. And we notice that, again, the denominators are the same. So this is a simple problem. Since the denominators are the same, we need only subtract the tops. So this becomes 2y minus 7 divided by 2y minus 7. Now notice here, these actually are the same terms, so this can actually cancel. So 2y minus 7 divided by 2y minus 7 actually gives you just 1. We'll do another example. In this problem, we're asked to subtract 10x minus 5 over x minus 1 from 3x squared plus 2x over x minus 1. We notice the denominators are the same, and so we can just subtract the tops. Now be careful, the top, the second portion of the top has to actually go in parentheses because you're subtracting the entire thing. So if we do that and have the same common denominator, we get 3x squared plus 2x minus 10x minus 5 all over x minus 1. Now notice we have to actually distribute this negative sign through the second expression, and if we do that, what do we get? Minus 10x, and a minus times a minus gives me plus 5. So now we can combine like terms. Well, the bottom is the same denominator, but the top there are like terms. We can combine the 2 minus 10x to become negative 8x. So combining our like terms on top, what we get is 3x squared minus 8x plus 5 divided by x minus 1. Now some of you may be thinking, well, this looks like a trinomial, and maybe I can factor that trinomial, and you can. You can actually factor 3x squared minus 8x plus 5 into two binomials and possibly simplify this. So let's do that. We notice 3x squared minus 8x plus 5 will factor into 3x minus 5 and x minus 1. You can try foiling this back out to see that you get that trinomial. And we notice, therefore, that we have a common term, both top and bottom, of x minus 1. So a common factor, so we can cancel those out. And so my actual final answer is 3x minus 5. So by subtracting those two rational expressions, we end up with 3x minus 5. Now what happens if you don't have a common denominator like we have here? So that common denominator is not always there. So what do we do? What do we do when we have fractions? Well, we have to find, the first step was to find the LCD.